Today, I would like us to take a stroll into the world of measurements and SI units. Before I go into the world of measurements, I'd like us to have a basic understanding of the essence of measurements in science as related to our everyday life. In the last lecture, I talked about how principles and theories are not just formed, but must have gone through a series of experiments in order for them to be proven through, or at least to be able to explain those principles. Now, in the course of these experiments, concise measurements are made. Take note that in chemistry, most of the concepts are derived from the measurement of observations. So, chemistry deals with the measuring of what? Observations. That brings us to the concept of measurements and SI units. Now, what is measurement? Measurement is simply assigning an equivalent numerical value to an observation or a property of matter or matter itself. So, we could say that if I rub my palms and I feel heat, we could actually assign a value to the amount of heat that was felt. Having understood the concept of measurement, I would like us to understand that when an observation or matter is measured, it is referred to as a physical quantity. You measure an observation and you ascribe a numerical value. When an observation is measured, it is called what? A quantity. If I can measure the temperature of a body at a particular time, does that mean temperature is a quantity? Yes, of course. Temperature is a quantity. Now, in the concept of measurement, we stated that it is simply giving values to observations. For instance, I could say, how long does it take me to walk from home to school? Or I would want to say, how much time or how far do I cover when I walk from my home to Kilimanjaro? That brings us to answering the questions using measurement. In this sense, we could say that in measuring these quantities, we require what we call measurement tools. These quantities that can be measured are of different types. Some quantities are dependent on others, while some are the basic quantities. Those quantities that are dependent on other quantities to ascertain their numerical value are called the derived quantities. While the others, which we refer to as basic quantities, they are the standard upon which the derived quantities are gotten. Those are called the what? Fundamental quantities. The fundamental quantities, there are about 7 of them until scientists are yet to discover some others. We have mass, we have length, time, we have some others like luminous, intensity, amount of substance, and so on. But these 3, the mass, the length, and the time, are the basic quantities. So they are referred to as the fundamental quantities because other quantities are derived from them. For the derived quantities, we have acceleration, we have force, we have quantity of electricity, and so on. Now, remember I said in the measurement of these physical quantities, we require what we call measurement tools, as well as what we call a measurement system. These measurement tools are graduated, that is, they have numerical values that are used to measure these physical quantities. And these tools measure these quantities using units. The measurement tools use units to measure the physical quantities. For example, in measuring the physical quantity, mass, we could use a beam balance. And this beam balance measures mass in kilogram. We say that the unit of mass is kilograms. Let's take, for instance, peradventure you want to measure the distance you walked from home to school. You could use a measuring tool, any of which could be a measuring tape. In the ancient times, they used your foot span to measure the distance that was covered. In using your measuring tape, you would see that it is actually graduated. That is, it has numerical figures that could be used to measure distance. We say that the length or the distance covered when I walk from school back home or from home to school using my measuring tape is 20 meters. So length could be measured with a measuring tape in meters. Now that we have a basic understanding of why or how observations are measured and the units that are involved in measuring these physical quantities or observations, I'd like to give us a comprehensive or just a little table of other derived and fundamental quantities, as well as the units. If I need to measure a physical quantity, let's say time, I would use a stopwatch, a clock, or any other measuring tool that could be used for measuring time. These tools are graduated, like I said. They measure time in the unit seconds. If I want to measure mass, the amount of matter in a substance, I could use a beam balance and it is measured in kilograms. Now, kilograms is represented as kg. And if I want to measure length, it is measured in what? Meters, which is represented as m. And then, let's take for instance, I want to measure a derived quantity, force. Force is simply mass times acceleration. And so if we have force to be mass times acceleration, I simply see that force is gotten from the combination of mass, which is a fundamental unit, and acceleration, which is another derived unit. If you go further into breaking acceleration, we have that acceleration is the velocity that a body takes to travel a distance per time. And velocity is also a derived unit. Velocity will be giving us the distance traveled per time. We could see that there are other physical quantities that are fundamental. For instance, the amount of a substance is measured in moles. And is represented as MOL, mole. And then we have luminous intensity measured in candela. We also have that current is measured in amperes, as well as temperature is measured in Kelvin. This is practically a table that shows the fundamental quantities, the derived quantities, as well as their units and symbols. Remember that distance can be measured in anywhere on earth, but most things in life has to come to a point of uniformity, a point where we could be able to have a standard value. In the course of trying to have a standard value of measurement, the National Bureau system was made. And this system was later advanced to an international system by the United States. The units were placed under a category we call the SI unit or SI system of units. The difference between the NBS standard of measurement and the SI system of units is that the SI system of units is depicted in decimal forms. That is, you could measure these observations or properties of matter down to little amounts in decimals or fractions. Of course, the fractions will be converted back to decimal. If you could remember, while we were growing up, there was this cubic measurement table. You find it at the back of most of the notebooks we use. I remember one of those measurement system, especially the one of time, that says 60 seconds make 1 minute, 60 minutes make 1 hour, 24 hours make 1 day. And so I'll give you a table of the decimal system of measurement, which was propounded by the SI unit system. We have that the system of measurement goes with prefixes, and then we have their decimals. For the first, we have 10 raised to the power minus 1, which gives us the milli. We have 10 raised to the power minus 2, which gives us what? Centi. We have 10 raised to the power minus 3, which gives us deci. 10 raised to the power minus 6 gives us micro. 10 raised to the power minus 9 gives us nano. 10 raised to the power minus 12 gives us pico. 10 raised to the power minus 15 gives us femto. 10 raised to the power minus 18 gives us atto. And then we will come down to the point of whole numbers. We have 10 raised to the power 1 to be deca. We have 10 raised to the power 2 and so on. So this table actually goes on down into a whole larger numbers. Having understood the essence of measurements in chemistry and the different quantities, that is, the fundamental quantities, mass, length, and time, as well as the derived quantities, force, acceleration, velocity, quantity of charge, which is actually what we refer to as ampere per second. And then I believe we now have a basic understanding of what a unit is and what a quantity is. And we could differentiate between a fundamental quantity as well as a derived quantity. Having explained all this, if you have any questions as regarding this topic, you could kindly drop them on the comment section. See you in the next class.